So now hopefully you have watched the content video for Chapter 2 containing information on sample problems A and B. This video will be on how to do the math for sample problems A and B, which you will then follow suit by using the guess method to do the practice problems A and B followed on the same pages in your textbook. If you do not have your textbook on you, if you log on to Miss Arter's teacher page, underneath my resources, the textbook web address, username, and password is listed there. Let's begin. Sample problem A. So first thing, after watching your guess video, we're going to do the same things that was listed there. During a race on level ground, Andra runs with an average velocity of 6.02 meters per second to the east. What is Andra's displacement after 137 seconds? So the first thing we want to jot down is things that we already know, variables that are given to us in the problem. So the first one that is given to us is an average velocity of 6.02 meters per second. Now it says to the east, guys, so is to the east implying positive or negative? To the east would imply a positive answer. All right, something else that we know is displacement after 137 seconds. Well, if the unit is seconds, what variable do you think that would be telling us about? That variable would be time. So nothing else is given to us in the problem. Now we can move on to our unknown. What we're asked to solve for is her displacement. Check out what units you already have. Velocity is in meters per second, and time is in seconds. So in order to get that velocity of meters per second, you had to travel so far in such an amount of time. So right there would be able to tell you, well, what units do you want us to solve for displacement in? Well, check out what velocity's units are, and that should be a helpful hint. In other words, displacement equals, I don't know, meters. Okay, so the next thing that we have is our original equation. Check back at your notes. You should see that your original equation is velocity equals displacement over time. So now it's time for that first S, that's substituting in. What we want to do first is rearrange the equation so that we can isolate the variable that we are solving for. The variable that we are solving for is displacement. The way that we can isolate displacement is by multiplying by t, time, on both sides. When we do that, the new rearranged equation becomes time times velocity equals displacement. All right, time out real quick. Check your variables. The units on your variables, are they good to go, or do you need to convert to anything? Well, looking them over, it seems like we are A-okay. So let's just plug in and get that calculated answer. Time is 137, and velocity is 6.02. Throw that in your calculator real quick, guys. Please don't just wait for me to tell you during this video. Be proactive here. Get your calculators out real quick, please. Cell phones, iPods, iPads, whatever you have. Calculate 137 times 6.02. Check that number out on your calculator. That number should come out to be 824.74. Okay, so that's the calculated answer. Now we're done with the first S. Let's move on to the last S. All that one is simply box your final answer with correct units and sig figs. Well, we know the units are going to be in meters, but how about the sig figs, guys? Check back at your givens here. Which given has the least number of sig figs? Well, 6.02 has 3 sig figs, and 137 has 3 sig figs. So your final answer should have 3 sig figs. Okay, do we need to round? 824, what's the 7 do to the 4? Does it round it up or keep it the same? The 7 would round it up. So therefore, our final answer should be 825 meters is your displacement. Hey, Miss Arter, grade this one. What do you need to do, guys? Box your final answer. Fabulous. Okay, so use this same method for now practice problems A. You're probably going to be using velocity equals displacement over time for the original equation for all of these problems. And just giving you a heads up, number 1 has 1 answer, 2 has 1 answer, 3 has 1 answer, 4 has 1 answer, 5 has 1 answer, And 6 has 2 different answers that you should be coming up with. Be careful about 6b. You should get a negative 77 kilometers per hour once it's all said and done. Now, maybe your math didn't show you that, but remember, in physics, positive and negatives do not imply positive and negative numbers, okay? It's your magnitude, 825 meters in this problem, for example, plus what direction, i.e. a vector quantity. So the magnitude is 825 meters and the direction is positive. In other words, check the problem out again here. She's running towards the east, so obviously it's a positive 825 meters. We just don't put the plus sign in front because if you have a number written there, it should be able to be assumed as positive. Whereas when you get down to 6b, you should solve through and get a calculator answer of 76.61, but you only want 2 sig figs, so 77 kilometers per hour is kind of sort of the right answer. You need to make it a negative 77 kilometers per hour because you're traveling towards the south for the final answer there. So please make sure you just make sure that things are in the right units. Also remember your negative, your odd answers are in the back of your textbook to your practice problems, so you should be able to at least get half of them right. Show us that you applied the guess method to each problem. You get a point per problem that you applied the guess method to, and these will be due tomorrow. Let's move on to B now. Sample problem B. We're on page 49 in your textbook now. So this section was about average acceleration. Here's your problem. A shuttle bus slows down with an average acceleration of negative 1.8 meters per second squared. So stop and think about that. Why is it a negative 1.8 meters per second squared? Because it's slowing down and not speeding up. How long time does it take the bus to slow from 9.0 meters per second to a complete stop? So stop and think about that. If the bus comes to a complete stop, 0 meters per second, would that be your initial velocity or your final velocity? What I'm trying to get you to see here, guys, is it may be words, not necessarily numbers, that are giving you variables in the problem. All right, let's pull out some of these givens. The first one we come across is an average acceleration, don't forget your negative, of negative 1.8 meters per second squared. The next one we come across is 9.0 meters per second. Okay, so assess it, guys. Do you want VI or VF? It goes from 9.0 to 0 meters per second. So initially, VI, you were traveling at 9.0 meters per second. And then finally, you're traveling at 0 meters per second. You know, once again, thinking back to that guess method video, do you want me to put 0 or 0.0, Miss Arter? I don't care. 0 nor 0.0 have any sig figs, so whatever you want to write, as long as you include it. Okay, so nothing else is given to us. What are we asked to solve for? How long does it take? Well, that would be how much time are we traveling? The units that you want to apply to this time would be seconds because they are present in all of the other variables in the givens, and that is a measurement of time that you would want to use in physics. So that takes care of our G and our U. How about our E, the original equation? Well, from your notes, you should know that average acceleration is change in velocity over change in time. In other words, delta V over delta T. That delta, that triangle, just means change in, and you just use the word delta instead of saying change in. Okay, but change in means like the difference between them, right? So really what we're looking at is V sub F, minus V sub I divided by T sub F minus T sub I. Is that necessary to do that though? What looks goofy about this? So stop and think, okay? Don't like just get into this system of doing things. Check this out, guys. Here's your unknown right here. Does it say anything about Ti or Tf? No. So you don't need to do that. Let's just keep that a delta T. Make sense? So really what we have is A average equals VF minus VI divided by delta T. Much better. It's starting to look like your givens and unknowns, right? Much easier to work with. Okay, but once again, this is your original equation. This is your substituting in. Now we want to rearrange it so that we can isolate the delta T. Let's multiply by delta T on both sides and divide by A average on both sides. So that simply gives us delta T equals VF minus VI over A sub average. Whereas VF is 0 and VI is 9.0 and your average is a negative 1.8. Put that in your calculators real quick. Please don't just wait for us to give you the answers. You have a negative 9 or just 9, doesn't really matter, divided by 1.8. When that comes out, you should be able to see 5 on your calculator. So now that you have this calculator answer of 5, maybe some of you got negative 5, which I'd like to chat about in a second. Let's look at our final answer. Delta T equals not just 5, because that's only one sig fig. Check the givens out that are applicable here. Notice how VF, it doesn't apply, right? Because there's no sig figs, so why even try to consider it? You have to have some sig figs to have a final answer. So your final answer is going to have 2 sig figs because 1.8 is 2, as well as 9.0. So what do you need to add to this is kind of like a placeholder, but it ends up counting because there's a decimal. That would be 5.0 seconds, and box it. Okay, so for those of you that at this step right here, you got a negative 5 on your calculator because you did 9 divided by a negative 1.8, number 1, we are in physics. It is not positive and negative numbers. Okay, it is numbers that have a direction applied to them. Once again, that negative 1.8 just means slowing down instead of a positive 1.8 speeding up. So if you did get a negative 5, stop and think about that, guys. If you have a negative 5, what does that imply about your time? If you have negative time, what were you doing? You're going backwards in time, right? This bus can't slow down going backwards in time. Not at this level of physics, at least. Okay, so that should be a really good indication that, once again, these signs are just implying direction, not numbers, okay? So you should not have a negative 5 for your answer there. Once again, the final answer is 5.0 seconds. Use your average acceleration equation here to figure out your practice problem B's. And real quickly, number 1 should have 1 answer, 2, 1 answer, 3, 1 answer, 4, 1 answer, and 5 should have 2 answers. Also, once again, the odd answers are in the back of your textbook. Good luck with these. Make sure that you do them so you receive your practice problem points.